Oh, hello again. This is Lesson 11, Comparing Ratios Using Ratio Tables. In our first classwork, Example 1, we are to create 4 equivalent ratios, 2 by scaling up and 2 by scaling down, using the ratios 30 to 80. Okay, so let's start by scaling down. When you scale down a ratio, you divide both sides by the same number. Remember that constant C before? We had to multiply both sides by the same number. That's an example of scaling up. So let me show you what that looks like. Okay, here we go. Bring our stuff over here a little bit. So if we divided both sides by 10, we would have 3 to 8, and then you could continue on from there. 6 to 16, 9 to 24. If we were to multiply both sides by 2, then we would have 30 times 2 is 60, 80 times 2 is 160, and then from there we could continue on. 60, 90, 120, 16, 24, 320. So that's a little bit of scaling. We can talk more about that in the future. Moving on, our next example asks us to write a ratio to describe the relationship shown in the table below. And let's move the table so that we can see it. All right, if we look at this ratio table, we have in 2 hours, 16 pizzas are sold. In 5 hours, 40 pizzas. In 6 hours, 48 pizzas. And in 10 hours, 80 pizzas. So we want a ratio to describe the relationship shown in the table. Well, let's start with this. Let's try writing the value of this first relationship, this first ratio here. 2 to 16 is a ratio. Right away, I can notice that this ratio can be simplified. So can we simplify this by dividing the numerator and the denominator by 2? 2 divided by 2 is 1, and 16 divided by 2 is 8. So if we simplify this, we can say that the ratio is 1 hour, 8 pizzas. Let's just check 5 to 40 to make sure we're on the same page and that we get the same simplification for each one. We divide the numerator and the denominator by 5. 5 divided by 5 is 1. 40 divided by 5 is 8. So I can clearly see that if we rate all the value of each one of these as these ratios, we would, and then simplify them, we would get 1/8. So then we can say, for an answer to this, the ratio used to create this table is 1 to 8, which means that there are 8 pizzas being sold every hour. Every hour means 1 hour. So what that means is that to start this table off, we really had 1 over here and 8 over here. We just didn't put them on here. We started with 2 hours. That's what it means to describe a relationship, a ratio relationship with this table. All right, let's move on to the next exercise. Okay, so in exercise 1, the following tables show how many words each person can text in a given amount of time. Compare the rates of texting for each person using the ratio table. So for Michaela, in 3 minutes she can text 150 words. In 5 minutes, 250. In 7 minutes, 350 words. And in 9 minutes, she can text 450 words. Go ahead and look at Michaela, Jenna, and Maria's words per minute. Okay, so we are to compare the rates of texting for each person using the ratio table. How can we compare the texting rates? Well, this can be difficult because it doesn't seem to have a common time for all the rates. If you noticed, we have 3 minutes, 4 minutes, 2 minutes, 4 minutes, 3. So how exactly do we compare these rates? So even though there's not a not a time that is common to all three tables? Like they don't all have 3 minutes, they don't all have 5 minutes. Is it still possible to use the tables to determine which girl has the fastest texting rate and which has the slowest? Can we still do it? Is there a way? Well, could we compare the first one and the third table, because they both have 3 minutes? Or maybe the second and third, because they both have 6 minutes. We can kind of look at those numbers. So if you use ratios to compare, what do the ratios mean in the context of this problem? So what exactly does this mean? 3 to 150. Well, it means that for every 3 minutes, Michaela types 150 words. And then in every 5 minutes, she types 250 words. Every 7 minutes, she types 350 words. How can we use these ratios, the 2 minutes to 90 words, 3 minutes, Maria types 120 words. How can we use these ratios to help us compare the texting rates of the 3 girls? Can we find the values of the ratios and then put them in order, maybe? What's the value of this one? 3 to 50. Remember, the value is the fraction, so 3 to 150 would be 3 over 150. Could we maybe use the values of all of these and then put them in order? Why can't I just pick the students who have the largest number of words at the end of the table? Why can't I just say that it must be Maria because she has the largest number of words at the end of the table? Why won't that work for me? Or will it work? Right, well, the minutes are not equal, so I can't really compare these. If you remember comparing with fractions, I can't really compare the value 9 over 450 with 12 over 480. I'd have to find a common denominator to compare them that way. That's a lot of work right now. But that is why we kind of can't compare them. Okay, well, what if there's a fourth person, Max? And on your paper, you see a fourth row for a fourth table for Max. And what if he can text 55 words per minute? How could we create a table to show his texting speed? Well, go ahead and fill in your table here and write out the ratios using this table. Well, what do you notice about the minutes now in your ratio table? Did you say that they increase by 1 each time? So it looks like figuring out the words per minute would probably help. I wonder if we could do that for all of these. Do you remember the pizza? Way back up here? How did we figure out how many pizzas were sold in 1 hour? Remember what we did? Yeah, we wrote it as the value, the fraction, and then we simplified it. So my question now is, can we do the same thing here? Can we write these ratios and simplify them? Let's try it. You try it on your own. All right. So if you look over here, and I wrote 3 divided by 3. I did the numerator and denominator the same. I simplified that to 1 over 50. Here I simplified dividing the numerator and denominator by 2 and received 1 over 45. When I divided the numerator and the denominator by 3 over here, I have 1 over 40. Now what this means is Michaela, if in 3 minutes she types 150 words, in 1 minute she can type 50 words. So what I'm going to do is right here, going to put my 1 minute and 50 words. And over here, for Jenna, she types, in 1 minute, she types 45 words. See how I'm taking my value and I'm putting it back as a ratio? Just another way of saying it. For Maria, in 1 minute, she types 40 words. So we have it now. If we were to put it in order, who types the most words? Of course, Max would win because he types 55 words in a minute. But then out of these three, we could say that Michaela types more words than Jenna and Maria. Because now looking at it this way, we can see how many words per minute. And when we have per minute, we can then say that this is a common way of looking at it. Every minute. It's very easier to see it, much easier to see it that way. Over here, we didn't have the minutes the same. But here we do. So Michaela types more words per minute than Jenna and Maria. And then Jenna comes in next, and Maria comes in last. So to go back here, to compare the rates of texting for each person using the ratio table, we can say Michaela texts the fastest because she texts 50 words per minute. Next is Jenna, who texts 45 words per minute. And last is Maria, who texts 40 words per minute. Okay, exercise 2, making juice and comparing juice to water. The tables below show the comparison of the amount of water to the amount of juice concentrate in grape juice made by 3 different people. Whose juice has the greatest water to juice concentrate ratio, and whose juice would taste strongest? Be sure to justify your answer. Well, the first thing we have to ask ourselves again is what's going on in this word problem. So the table is showing the comparison of amount of water to the amount of juice concentrate. Now, if you've ever made frozen juice, that's kind of what juice concentrate is like. You take some frozen juice and you put it into a pitcher, and then you take cans of water from that juice and you pour it in with it, and so that kind of helps. The juice concentrate doesn't have to be frozen. It can be something else. It can be a powdered concentrate or some other kind. But that's what they mean when they talk about the juice concentrate. So if you think about making juice that way, either frozen or with a powder, this might help us get an understanding of kind of what's going on here. So our question that we have to answer is, whose juice has the greatest water to juice concentrate ratio, and whose juice would taste the strongest? So there are 2 questions. Let's underline those questions before we go on. This is the first one. I'm going to underline it and I'm going to put it in bold so we know that that's a separate question from the second one. Whose juice would taste the strongest? Okay, those are the 2 things we're trying to figure out. So, whose juice has the greatest water to juice concentrate ratio is the first question. Well, Laredo's juice has 12 cups of water to 4 cups of juice concentrate. That makes a total of 16 cups. Franca's juice has 10 cups of water to 2 cups of juice concentrate, and Milton's has 8 cups of water to 2 cups of juice concentrate. So we can look and see we have a similar problem that we've already had. How do we figure out who has the greatest water to juice concentrate ratio? Well, let's try using the same way that we found before. Let's find the values for each ratio and then see if we can't get it down to its simplest form and see what we find out. So go ahead, take the 12 to 4, 10 to 2, and 8 to 2, and see if we can't find a way to find out which one is in the simplest form, if we can compare them then. Okay, so let's hoping that you did the same thing I did. I took the 12 cups of water and the 4 cups of juice concentrate, and I made a ratio of 12 to 4. I wrote it as 12 to 4. I made sure for me the water was on top, the juice concentrate was on the bottom, so I needed to make sure all of them have are written the same way, with the water on top and the juice concentrate on the bottom. Then I simplified it. I divide the numerator and denominator by 4, and I got 3 over 1. Okay. Over here, so that was Loretta's. I went back and put it back and said that, again, that the 3 represented the water, the 1 cup represented the juice concentrate. So then I went to Franca's. And I divided the numerator and the denominator by 2 and got 5 to 1. Again, I did the water for the numerator and the juice concentrate for the denominator, so I had to make sure I was consistent with all of mine and make sure they were all in that order. The water was 5, the juice concentrate was 1 cup. So then in Milton's, I divided the numerator and denominator by 2 because that's how I simplified it, and I came up with 4 to 1. So 4 cups of water to 1 cup of juice. Now, let's go back to our questions. Whose juice has the greatest water to juice concentrate? Well, it looks like Franca's has the greatest one because it has 5 cups of water to 1 cup of juice, and that's the most water. So Franca's was the one that has the greatest water to juice concentrate ratio. And whose juice would taste the strongest? I'm going to let you figure that out based on the information that you have in front of you here. Now, hopefully you figured out that with Laredo's only having 3 cups of water to 1 cup of juice concentrate, that this one will be the strongest one in terms of tasting like juice because you wouldn't have that much water in it. In Franca's, for the same cup of juice concentrate, you have 5 cups of water. In Milton's, for the same cup of juice concentrate, you have 4 cups of water. So Laredo's would taste the strongest. Now, if we were to put these in order, because in the bottom it says to put the juices in order from the juice containing the most water to the juice containing the least water, well, now that we have done all this work, it's pretty easy to see. It would be Franca's first, and then Milton's, and then Laredo's. We've already answered, put the juices in order from the juice containing the most water to the juice containing the least water. Now we need to explain how we use the values in the table to determine the order. What exactly did we do? So what I want you to do when you're explaining this is tell me what the ratios that we came up with mean. So when we had 3 water to 1 juice concentrate, what did that mean? Well, Laredo made his juice by combining 3 cups of water for every 1 cup of juice concentrate. Franca makes her juice by combining 5 cups of water for every 1 cup. And Milton makes his juice by combining 4 cups of water for every 1 cup of juice concentrate. And if you wrote numbers instead of these words, that is fine. All right, so let's move on now. This part is what ratio was used to create each table. Again, you've already got that information written down, so just go ahead and fill this information in here. Now, explain how the ratio could help you compare the juices. Here's where you put your words into what we did. How did the ratio help us compare the juices? Okay, B says the next day each of 3 people made juice again, but this time they were making apple juice. Whose juice has the greatest water to juice concentrate ratio, and whose juice would taste the strongest? Be sure to justify your answer. Well, this is what we've already done. Again, there are 2 questions to answer, and we'll underline and highlight them and bold them so that you know one question versus the other question. We've already done something similar to this, so you have an idea. I will give you the hint that you may not come up with a 1 as either your numerator or your denominator, but you may be able to still compare them because you may find that there is a number that is the same. So I will say nothing else. Have you go ahead and tell me whose juice has the greatest water to juice concentrate ratio, and then whose juice would taste the strongest. And let's just make sure that you have all of your ratios to look at. And you do. Okay, so if you did this, you found that it didn't come exactly the way the other one did. They don't all have any same number really. They're all different numbers. But we can still use this information to answer our questions. So one of the questions we needed to answer was, which juice has the greater water to juice ratio content? Well, it looks like Laredo's juice has the greatest water to juice concentration. There's far more water than there is juice concentration on this. So Laredo's is our greatest water to juice concentration rate. Now, whose juice would taste the strongest? That would be the one without the less water, so Laredo's kind of out of the running for that. So when we're looking at Franca's and Milton's, we probably could look at the first one. So, because these are similar, they both have 6 juice concentrates, 6 cups of juice concentrate. Franca's adds 15 water, and Milton's adds 16 cups of water. So the less water, the higher the concentrate, the more it tastes like juice. And so when we talk about whose juice would taste the strongest, we're going to say that it's Franca's. Franca's tastes the strongest. All right. Now, with that information, we are saying which one is the strongest to the weakest. Well, Franca's is the strongest. And then Milton comes next because we said that Laredo had the most water. So Laredo's has to be the weakest. So if we put them in order from the strongest to the weakest, it would be Franca, Milton, and then Laredo. Now, explain how you use the values in the table to determine the order. What exactly do we do? How do we figure it out? Values, remember, refers to the fractions that we came up with, and then turn them back into a different form when we're talking about them. Okay. Next was, what ratio was used to create each table? Well, Laredo's was 6:1. Franca's was 5:2. And Milton's was 8:3. You guys have it written down. All right. Moving on. Explain how the ratio could help you compare the juices. This is where I get to see how you're thinking. So, how do these ratios help you to compare the juices? Think about what we've done and tell me what you think. Lastly, how is this problem different than the grape juice questions in Part A? Go back and look at Part A and see how these were different. Okay, C says Max and Sheila are making orange juice. Max has mixed 15 cups of water with 4 cups of juice concentrate. Sheila has made her juice by mixing 8 cups of water with 3 cups of juice concentrate. Compare the ratios of juice concentrate to water using ratio tables. State which beverage has a higher juice concentrate to water ratio. So we don't really have a question here. In this case, we have just a statement which tells us a direction. It's kind of like our question. So we'll go ahead and have this one underlined. Try and figure this out, and then come back and see if we agree with our answer, with your answer. Okay, so here is a couple of tables, and as you can see, I've written it so that the water is on the bottom and the juice is on the top, because I talked about the juice concentrate to water, so I just did it that way. According to this now, if we were to take this and go a little further, and let's say we took Sheila's table, Max's table goes from 4, 8, and 12. Sheila's table goes 3, 6, 9. If we did one more, if we made the next one 12, because if we put 3 more, it would be 12, and we extended the table, and then here we kept adding 6, 8, we would get 16, 24. The next one is 32. Well, now you can see at this point that we've got a number that's the same. When we have a number that's the same, it helps us to compare. So the juice concentrate is the same at 12 cups. The water concentrate, however, is different. Whereas Max adds 45 cups when he adds 12 cups of concentrate, Sheila adds only 32 cups when she adds 12 cups of juice concentrate. So therefore, Sheila has a higher juice concentrate ratio juice concentrate to water ratio because she mixed 12 cups of juice concentrate to only 32 cups of water, while Max's juice would be more watery because he would have had 45 cups of water. So we were looking to see which one had more juice concentrate in it. In this case, it would be Sheila because she put in only 32 cups of water, whereas Max put in 45 cups of water. So that's where that answer came from. All right, moving on to D now. Victor is making recipes for smoothie. His first recipe calls for, let's move this down so we can read this better, 2 cups of strawberries and 7 cups of other ingredients. Other ingredients, okay. His second recipe call says that 3 cups of strawberries are combined with 9 cups of other ingredients. Which smoothie recipe has more strawberries compared to other ingredients? Use ratio tables to justify your answer. Okay, so again, we have to remember that what we need to find is what the question's asking us. That's when we need to underline. We need to think about what's happening in this problem. Now, it's a little different than what we've been working with, so take a minute to think about that. Okay, Victor is making smoothies, but his recipe calls for 2 cups of strawberries and 7 cups of other ingredients. So our ratio is strawberries to other ingredients. So with that in mind, go ahead and do a ratio table and see if you can answer this question. Okay, well, the question asks us which smoothie recipe has more strawberries compared to other ingredients. Well, it looks like recipe 2 has more strawberries compared to other ingredients because it starts off with 3 strawberries, then 6, then 9. But if you look at the 6, when they get to 6 strawberries, it has 21 other ingredients, whereas recipe 2 has only 18 other ingredients. So when you look at these, so when you look at 6 and 18, you'll see that there are more ingredients added in recipe 1 than recipe 2, which tells me that there are more strawberries in recipe 2. So our answer could look like this. Recipe 2 has more strawberries compared to the other ingredients. When comparing 6 cups, not 66, of strawberries, there were fewer other ingredients added in recipe 2, only 18, than in recipe 1, 21. But if you wanted to look further, we could also look at this in terms of the values. What if we had 2/7 strawberries to other ingredients, and we had 3/9 strawberries to other ingredients for recipe 2? What if, I believe in both these tables, you can correct me, but I'm pretty sure I'm right, 63 is there. What if we got all the way, and we could extend this table all the way until we were adding 63 cups of other ingredients? Okay, what would we multiply both numerator and denominator to get to 63? Right, we multiply it by 9. Of course, if we do it in the denominator, we have to do it in the numerator. That's the rule we've learned. 2 times 9 is 18. Over here, it's 9 times 7. 9 times 7 is 63. 3 times 7 is 21. And we've learned that when we have a common denominator, we can compare fractions a lot easier for ourselves. So you can clearly see here that there are 18 strawberries when they have 63 cups of other ingredients, but recipe 2 calls for 21 strawberries when there are 63 other cups of ingredients. So clearly now you can see that recipe 2 will have more strawberries when you compare the other ingredients. So there are 2 ways you could see this. This is called finding a common denominator, and we did that when we looked at the ratios and we looked at the value of the ratios. Remember, the value of the ratios are the fractions. Hopefully that was helpful. Okay, our lesson summary for today states that ratio tables can be used to compare two ratios. Look for equal amounts in a row or column to compare the second amount associated with it. So you would look for the amounts and see if you can find something like 30 and 30, because that helps you to compare the bottom part of it. The values of the tables can also be extended, which means you can continue on, in order to get comparable amounts. Another method would be to compare the values. Remember, the values means fractions when the ratios are turned into fractions. So the values of the ratios by writing the value of the ratio as a fraction and then using knowledge of fractions to compare the ratios. And that's what we did when we just looked at the strawberries. We turned the ratios, found the value of the ratios, so we turned them into fractions, and then we compared them by extending them to 63. When ratios are given in words, creating a table of equivalent ratios helps in comparing the ratios. So 12 to 35 compared to 8 to 20, we can look at 12 being quantity 1, 35 being quantity 2. Here's the important thing. The 8 to 20 has to stay the same. Quantity 1 has to be the 8, and then quantity 2 has to be 20. The way that we write it has to stay. The order matters. All right, let's get ready for the exit ticket. Okay, here's your exit ticket. Beekeepers sometimes supplement the diet of honeybees with sugar water to help promote colony growth in the spring and help the bees survive through fall and winter months. The table below shows the amount of water and the amount of sugar used in the spring and in the fall. Your job is to examine these two tables, these two ratio tables, and then write a sentence that compares the ratios of the number of cups of sugar to the number of cups of water in each table. So you need to write one sentence. However, then explain how you determined your answer. So you do need to spend some time explaining how you determine your answer as well. And that is your exit ticket. Do your best.